An amplifier is an electronic device used for increasing the amplitude of electrical signals. They are available in different classes, A, B, AB, C, D, and so on. In this video, we will explore the Class A amplifier, which uses only one transistor. You would know that the transistor can amplify the base current, by its gain, to the collector current. Hence, we will use the transistor to amplify the voltage applied at the base to a higher voltage at the collector. In this circuit, the output will always be VCC, as it is directly connected to the source. Thus we add a resistor between them. The voltage drop across a resistor is directly proportional to the current flowing through it, and the current through the resistor is equivalent to the collector's current, and the collector current depends on the base current, which depends on the voltage of the input signal. Thus any change in input voltage will change the output voltage, and the low voltage at the input is amplified at the output. When the input voltage is high, the current is high, hence, the voltage drop is high, and the output is low. Similarly, when the input turns low, the output goes high. The output has a phase shift of 180 degrees. But, the waveform looks distorted, because the gain of the transistor is very high, and it is getting saturated. To limit the gain, we need to provide feedback. Hence, we add a resistor between the emitter and the ground. As you know, the voltage drop across a resistor is directly proportional to the current flowing through it. Thus, when the base current increases, the collector current also increases. The increasing current increases the voltage drop across the resistors. Here, as the supply is fixed, the voltage at the other end falls. This drops the output voltage. And here, as the ground is fixed, the voltage at the other end rises, and this increases the output voltage. This provides negative feedback for the output, limiting the gain of the amplifier. The gain of the amplifier is now more dependent on these two resistors, rather than the gain of the transistor, allowing us to have better control over the total gain of the amplifier. The gain of this amplifier is given by the ratio RC to RE. At last, we add a capacitor to remove the DC bias and get the amplified input signal. You would know that a transistor requires 0.7 volts or above at the base to turn on. Thus, this circuit cannot amplify voltages below 0.7 volts. To make this actually work, we need to add a DC bias to the input signal, such that the input signal is always above 0.7 volts. And to do that, we add a voltage divider here. This will provide the required bias to the voltage of the signal. Now, a complete waveform of the signal can be obtained at the output. But, now the transistor is always on. Also, this DC bias voltage can interfere with the source of the input signal. Hence, we add a capacitor here. The capacitor will block DC from any of the directions and allow only the AC signal to pass. The input signal is first biased, such that it's above 0.7 volts, then the signal is amplified by the transistor, with the gain provided by the relation between RC and RE, and at last, the DC bias is removed to obtain the amplified signal. This is how a Class A amplifier works. This is the simplest type of Class A amplifier circuit. We can add more components to it for improvements. In this circuit, the biasing resistor is connected after the RC. When the input voltage increases, the base current increases, which increases the collector current, and the voltage at the output falls. This also drops the bias voltage, thus the base current drops, collector current drops, and the voltage at output rises. This resistor now provides the negative feedback, and limits the gain of the amplifier. This circuit has a capacitor across this resistor. This increases the AC gain of the amplifier. The capacitor will block the DC. Thus the amplification of DC will depend on the resistors, but for AC, the capacitor will act as a short circuit. Its gain will depend on the beta of the transistor, which is in hundreds. Thus you can amplify a very weak signal to strong signal. This circuit uses the Darlington transistor in place of the single transistor. Darlington transistor is two transistors within a single package, one small pilot transistor and another larger switching transistor. This increases the current handling capacity and gain of the circuit. Also, this provides high impedance at the input and low impedance at the output. This circuit has a transformer, in place of RC, to increase the efficiency of the circuit. However, the transformer is an inductive device due to its windings and core, so using inductive components in amplifier switching circuits is best avoided, as any back EMFs generated may damage the transistor. A Class A amplifier can reproduce full waveform, with very low distortions, but as the transistor is biased, it's always on. This and some other factors reduce its efficiency to less than 30%, which is very low. Now you know how a Class A amplifier works. In the upcoming videos, we will explore the remaining classes of amplifiers. Thank you for watching.